Hello, hope you are enjoying my lectures. Today I will spray some light on the Solow model of economic growth. And and you should remember that there are a number of questions in IS examinations or national level net examinations for college teachers or university teachers from the Solow model of economic growth. It is much more important in macroeconomics, and one should have a clear idea over this growth model. Otherwise, there would be a number of questions, and you would not be able to answer those questions. So, keeping this view in my mind, today I will be discussing the Solow model of economic growth. Okay, the Solow model of economic growth and the Harrod model of economic growth. What is the basic difference? The basic difference between the two models is that the capital output ratio is constant in the Harrod model, but the capital output ratio is changing in the Solow model of economic growth, and it happens because in the Harrod model, the real rate of interest, that is the factor prices, the real rate of interest, the real wage rate, all are flexible. All are constant in the Harrod model, but they are flexible in the Solow model of economic growth. In the Harrod model, as they are fixed, there is a fixed capital labor ratio and fixed capital labor ratio, and so there is a fixed capital output ratio. So, but in the Solow model, but in the Solow model, there is a change in the real rate of interest. There is a change in the real wage rate. And in a competitive economy, as the factor price is determined by the marginal productivity of the factor. So real rate of interest is determined by the marginal productivity of the capital. So marginal productivity of capital market is determined by the mm, is determined. So so the capital lever ratio, if the factor price is changes, the real rate of interest changes. So capital output ratio changes. As capital output ratio changes, so so capital output ratio changes. Here is the basic difference between the Solow model and the Harrod model of economic growth. And also there is another difference in the Harrod model. Investment function is independent, but in the Solow model of economic growth, the investment function is not independent. It is the rate of change in the capital stock. Okay, so so keeping keeping all this thing in my views, uh, uh, before before going into depth, and the Solow, it should be remembered that the Solow, Swan, and Phelps are the neoclassical economists, who actually worked on the neoclassical approach of economic growth. So aggregating aggregate production function. Aggregate production function. What is the aggregate production function? You can find this y equal to function of LKT. This is the aggregate production function. Okay. Now, as in the Solow model, investment is equal to the change in the capital stock. Change the I equal to dk by dt. So now I am going to my next slide. Look, if if you have a look here, the aggregate production function is assumed to be linearly homogeneous in labor and capital inputs. And in absence of technical change, there is no technological progress. Then the aggregate production function can be written like this. Okay. So if the aggregate production function, if the aggregate production function is as follows: y equal to function of L, K, and T, and then it is a linearly homogeneous function, and so we multiplied by the theta, and we get, and here we label capital and T also multiplied by the theta, and replacing theta by 1 by L, we get this. Okay, we get this, and this can be written very simple way: y by L is equal to function of k by L. K by L is nothing but a small k, capital leverage small k. So now I am using all my markings, otherwise I will not be able to move to my next slide. Okay, so now the aggregate production function, here the aggregate production function is diagrammatically represented. And look, along the vertical axis, we measure the output income per head, and along the horizontal axis, we measure the capital labor ratio. Okay, now this is, and this is the output per head curve, and output per head curve, and the slope of this curve is the real rate of interest, because slope is means the del fk del fk small k del fk by del k. So marginal, so marginal, so marginal, marginal productivity, so marginal productivity of capital is the rate of interest, and this is the slope of this curve. This is the slope of this curve. Here AB represents the real rate of interest and B0 represents the real rate. Now, now we, and this is the equilibrium K0. Equilibrium K0, that means the capital leverage. Now I erase all this marking. So in the next slide, you can see that now we'll 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 spread some light on the saving function. You should remember that in the Harrod model, the saving is determined by the permanent income hypothesis. So in the Solow model, also saving is determined by the permanent income hypothesis, is a fixed proportion of the real income. And so here the saving is the saving per head. Saving is divided by the total labor. So saving S by L is the saving per head. But the Harrod model, it was like that: S equal to small s by y by small s multiplied by small y. Okay, this is the condition in the Solow model, in the Harrod model. Sorry, in the Harrod model. In the Solow model, it is like this. Now the rate of interest. The rate of interest, since there is a competitive market, so real rate of interest is determined by the del y by del k. That is the marginal productivity of the capital. That is the marginal productivity of capital. So, and this can be written like this, because small y is function of k, function of k. So d by dk labor, capital leverage. Okay, capital leverage. So this is the marginal product of capital, then the real rate of interest. Now the real OS rate. What is the real OS rate? Real OS rate is in the same way is the marginal productivity of the labor. The marginal productivity of labor. This is the mathematical terms, but in economics is the marginal productivity And marginal productivity of labor, that is the real wage rate, is the difference between the output per head. Output per head is the output per head minus the capital per head multiplied by the real rate of interest. It is the profit. It is the profit. It is the profit. So the W is the difference between the output per head, and it is the output per head and the amount of output per head paid out as a profit. Okay, output per head, and it is the difference between the output per head and the amount of output per head paid out as a profit, where profit is the product of the real rate of interest and the capital labor ratio. So this is the understanding. Now I am I am erasing all this marking. Look, now the final equation in the Solow model is the equilibrium condition for the product market, which is written in terms of the investment and savings per unit of labor input. So this is so so this is the investment saving equalization. Okay, this is the equilibrium condition in the product market. But investment per head and it is savings per head. You should remember that there are 7 equations in the Solow model. One is the investment function, another is the saving function, and third one is the equilibrium in the goods market, and aggregate production function in the fourth one, and the long run labor supply function, demand for capital stock, sixth equation 6, and demand for labor. Okay, so this is the investment function. This is the investment function. Okay, this is the saving function I have mentioned already. This is the equilibrium condition, equilibrium in goods market. I have also mentioned it. Okay, now this is the aggregate production function. I have also mentioned it. Now this is the labor equal to L0 e to the power mu t. Mu is the exogenous exponential rate at which the labor force is increasing. And in my Harrod model, you can find it. So it is the labor long run labor supply function. Okay. Now this is the demand for capital. This is a real rate of interest. It is also it has also proved, and this is also the real money wage rate. Sorry, the real wage rate, and this is also proved. So by solution, there are 7 unknowns. There are 7 unknowns. One is I, one is I, another is K, L, S, small y, rho, and small w. Okay. So these are the 7 unknowns. So there are 7 equations and there are 7 unknowns. So no problem is there. So these equations can be solved, and by solving this equation, we can get the warranted rate of growth that is adjusted to the natural rate of growth. That is adjusted to the natural rate of growth by changing the factor prices, by changing the real rate of interest, by changing the real wage rate. Okay. If the warranted rate of growth is greater than natural rate of growth, such type of situation is there, then the real rate of interest will decline. As real rate of interest decline, there is an increase in the capital stock. So as there is an increase in the capital stock, so there is an increase in the capital lever ratio, and there is an increase in the capital output ratio. Okay, there is a increase in the capital output ratio, and it was mentioned in the Harrod model. And in the Harrod model, warranted growth is nothing but the small s by w by nu. If nu is increased, if nu is increased, the warranted rate of growth will fall. So if the warranted rate of growth is greater than the natural rate of growth, this is the way in the Solow model. In the Solow model, the warranted rate of growth will be equal with the natural rate of growth in the long run. Okay, so the opposite will happen. Understand? Hope you will understand. Now I am erasing all this. I am erasing all my markings. So now the first 5 equations of the Solow model can be solved in per capita terms to get the following relationship. Here is another relationship that is very much important in the Solow model. So what is the relationship? The relationship is the rate of change. The relationship is the rate of change in capital per head. Rate of change in the capital per head is equal to the difference between the savings per head and the capital accumulation per head. Okay, and this relationship can be established by the following way. Look, this is the I equal to S. This is the goods market equilibrium condition, I equal to S. Now I equal to 1 by L dk by dt. It has been proved. It has been proved. So I replaced I by this, and S is equal to the S multiplied by the Y by L. It also mentioned, so I replace S by S multiplied by the output per head. Now 1 by L dk by dt equal to S function of small k. Okay, and it is also Y by L equal to function of small k. It is also known to us. Now we differentiate both sides of this equation by differential formula. I solve this equation. I get dk by dt 1 by L dk by dt minus k by L 1 by L dl by dt. Okay, I hope you understand. It is by using the mathematical differential formula, I have solved it and get it. Now by rearranging this 1 by L dk by dt equal to dk by dt minus mu k. Small k is nothing but it is known to us the small k is nothing but a k by L. So k by L is small k, and this is nothing but the mu. 1 by L dl by dt is nothing but mu. So it is nothing but the rate of increase in the lever force. It is known to us that the lever force is increasing at exogenous exponential rate mu. So 1 by L dl by dt is replaced by mu. So now we substitute 1 by L dk by dt by substitute for 1 by L dk by dt. We get dk by dt mu k plus s, because dk by 1 by L dk by dt is nothing but this. Okay, so we get this. Now after rearranging we get the final relationship. It is the very crucial relationship in the Solow model. You should remember and understand it. What is this? So dk by dt, the rate of change in the capital stock, rate of change in the capital stock is the difference with the savings per head and the capital accumulation per head. Okay, and on the basis of this, we will explain further. Now I am erasing all this marking. Okay, otherwise I will not be able to move to my next slide. Look, this is the Solow neoclassical model. This is the graphical representation. This is the graphical representation of the Solow neoclassical model. Along the vertical axis, we measure the Y by L mu k, and the that is the capital per head and the savings per head. And along the horizontal axis, we measure the capital leverage. Okay, and this is the curve of output per head, income per head, and this is the capital accumulation per head curve, and this is the savings per head curve. Okay, the savings per head curve. So in my previous slide, I have shown that the a relationship, that the rate of change in capital per head is the difference between the savings per head and the capital accumulation per head. So this is the equilibrium point. This is the equilibrium point. Okay, where the both is same, both are same. That is the capital per head and the savings per head same. And here the income per head curve is increasing per head diminishing rate. Why? Why? Because look here, the it is increasing at a diminishing rate because when the capital stock is increasing, when the capital stock is increasing, mu k increasing at the same rate, but the savings per head increases, but not at the similar rate of capital increase in capital, increase capital per head. There's a difference between the rate of increase in the rate of increase in the capital per head and the rate of increase in the savings per head. And it is less, savings per head is less than the capital increase in the capital per head. So for that reason, it is increasing. Y by L is increasing, but at diminishing rate. Okay. So now look, if we take a point to the left of K0, we take a point to the left of K0, then we get that savings per head is greater than the capital accumulation per head. That is with dk by dt, dk by dt is greater than 0. As dk by dt is greater than 0, so there is a it will come to the point k0, to the point k0, and there is a positive, that is it is greater than h by k, savings per head is greater than the capital stock per head. But when there is a negative relationship, negative, dk by dt is negative, when dk by dt is dk by dt, the rate of increase in capital per head is less than 0. Okay, less than 0. Then what will happen? It will happen that the savings per head is less than the capital accumulation per head. When it is when dk by dt is less than 0, it will decline. The capital per head declines, and output accumulation will decline at the same rate, but it will decline, or savings per head will be declining, but at a lower rate. So the so we get ultimately the K0 point. This is the equilibrium point and constant point. This is the equilibrium point where the mu k, that is the capital accumulation per head, and the savings per head is equal. Savings per head is equal. On this explanation is on the basis of our previous equation that shows the rate of increase in the capital per head is the difference between the savings per head and the capital accumulation per head. Okay. Now we move to our next slide. I am erasing all my markings, and now I move to my next slide. Okay. Look, now if suppose dk by dt is 0, if dk by dt is 0, what will happen? What will happen? Mu k, that is the capital accumulation per head, will be equal to the savings per head. Will be equal to the savings per head. Now, after rearranging, we get mu equal to sy by l, because fk is y by l k, and small s k by y by l. After arranging, we get s by nu. After arranging, we get s by nu. So mu is equal to s by nu. So what does it mean? It means that natural rate of growth is equal to the warranted rate of growth. It is nothing but the relationship between the natural rate of growth and the warranted rate of growth. Okay, it is the natural rate of growth and the warranted rate of growth. So when the rate of increase in the capital per head is 0, that means that the rate of increase in the savings per head is equal with the rate of increase in the capital accumulation per head. Both the natural rate and the warranted rate are same. Now, if you have a look, then if the if one's like to increase the savings, then it will not have any effect. This is does not have any effect on mu, because mu is exogenous exponential rate. Exogenous exponential rate. So at which the labor force is increasing. So there it has no effect. It has no effect. So in the long run, warranted rate of growth is equal to the natural rate of growth. But look, if in the short run, if s increases, and then what will happen? You can see in my previous slide. Okay, what will happen? If savings, look, if savings, this is the savings line. If savings increases, it will shift to up, and new equilibrium will get at new capital labor ratio, at new output per head, at new output per head. Understand? So if saving increases, so there is a equalization between the savings per head and capital accumulation per head, and at a new capital lever ratio, and we get a new labor output per head. But but this is, we can find it in the short run. In the long run, it will come back to this point. It will come back to this point where the dk by dt equal to 0. Okay, so it's the constant capital leverage. So it is the it is the result of the increase of S on the economic growth, savings ratio on the economic growth. Now, therefore, the equilibrium growth value of Y, and from this we can calculate the equilibrium growth value of Y. Equilibrium growth value of Y is mu by S multiplied by the equilibrium capital level ratio and the total level. And the total level. What is the mu by S? Mu by S is nothing but mu by S, mu by S is nothing but 1 by mu. 1 by nu. What is nu? Nu is the capital output ratio. And what is 1 by nu? Capital output capital ratio. Output per capital. Nu output per capital. So mu is output per capital, and this is the output per capital, and this is the equilibrium capital level ratio, and this is the total level. This is the total level. And so the equilibrium growth value of y is this. So what we have found in this lecture, of the Solow model, it is very clearly understood that what is the basic difference between the Harrod model and the Solow model. In the Harrod model, there is a constant capital output ratio and fixed real rate of interest and fixed real wage rate. So, on the other hand, in the Solow model, there is a flexibility in the real interest rate and the real wage rate, and as a result, the capital output ratio alters in the Solow model. And by Solow, by solving his equations, found that the warranted rate of growth that is adjusted to the natural rate of growth by changing the real rate of interest, by changing the real wage rate. So this is the fundamental understanding of the Solow model. I tried my level best to to fill the gaps, to fill the gaps. So I hope this lecture will be beneficial to all of you for the competitive examinations of the national level, and you will have a clear idea of the macroeconomics, and that's all for today. And thank you for watching this lecture.